And if you would allow all the clients to go directly to the subsystems, you get a lot of problems over the time. You have to. Each client has to know the subsystems he's entering. So you have a lot of more than just 1, 2, 3, 4 associations to this system here. Maybe like 20. So, second is if the subsystem is changing, you have to tell everyone who is using this subsystem, I have changed. And you have plenty of clients who rely on this subsystem. You have plenty of people to tell that they have to change something. If you have a facade, maybe you can change the subsystem without telling the people that they have to change something, because you change the facade and they don't see that something has changed. You hide the complexity of your systems behind the facade. That's the idea behind it. It's a very simple pattern from its design, but it's one of the most powerful ones. So, you hide complexity, you hide structure, and for them it's much easier. They know everything I want I get from the facade. If it's not there, I have to ask the people, please supply it from me. So, the facade is typically used when a simple interface is required to access a complex system. We have a complex system, but we supply only a simple interface to people. Some people only want to know very little out of the large system. The system is very complex and difficult to understand. If it is like this, then you have to tell every client that how complex it is, and he has to learn the system. If you supply just a simple interface or facade, then it's better for the one who wants to use it. Yes, an entry point is needed to each level of layered software. So we don't need that, because we have this facade, then it's one point where they touch our systems. Abstractions and implementation of a subsystem are tightly coupled. We don't know how complex systems are. Some systems are well developed, some are not. Maybe you have legacy systems, old systems. You still want to have data in it and you need to use it. Then you do not want that everyone wants to learn how this old system does work. Maybe it's a different language, maybe it's a different database, maybe, we don't know. Different infrastructure. So we supplied just a facade. Years ago I had one of my best friends had a company, and he had developed a system for scheduling. Doesn't matter what exactly it was. And they had a graphical user interface they had bought from another company. But this interface didn't develop as well as, for example, Java interfaces or interfaces developed, and it was not compatible to the internet. So he faced the problem that he had to invest a lot of money to modify his system for making it able to work on the internet. So he asked me, his main engineer, he asked them, and he said, yes, we have to completely redevelop the system. And it costs 1 year work, and it just cost 10 million, and we have to do it. And I said to my colleague, I don't think so. I think all what you need is a facade that your system is supplying, that you can show the results in the internet. So he went to this engineer, and the engineer said, no, that doesn't work, because we It's difficult for us to supply us a facade, and the system then is still old, and everything was bad. So my friend went to find someone who was supplying these 10 million, because the company didn't have so much money. We want to find an investor. So they found an investor. The investor looked at the system, and then they said to him, "No, we don't want to invest, we buy you. We give you more money, but we buy your company." So my colleague at that time was about 50, so he thought about what to do. So he decided to sell the company and get rich. So he's now a rich man. The interesting point is what happened after that. The American company, a large American company, sent some software developers to the company. And software developers looked at the situation. And it was an American company. And they said, "Oh no, we don't redevelop all the systems. We just make a facade for the internet." And they said to the top developer, the main architect, "If you don't like it, well, you know where the door is, you can go. Or you do it as we are like to do it. We don't invest 10 million here, we just invest 500,000, and then it's done." So he has to accept to do it like he didn't want to do it, or to leave the company via the door. So facade is a very, very important thing to make large systems, subsystems, anything, give an interface to a small interface, a handleable interface, to any kind of other systems. My friend is still rich, it's fine, and developed a small, consultant company now. Consultant. So he took some of his workers with him, but they don't develop software anymore. They just give consultants in this area where they have used to develop software, and just have different products. Yeah, good consulting. And he says, "It's just because I have nothing else to do." It's not nice to sit at home and just. Okay. So here another view that you get an impression how a facade really works. You have this subsystem, and the facade is interacting with different classes, but the client is only seeing the facade. Okay? One subsystem can supply plenty of facade, because you have different requirements, and you have maybe different facades. Here's an example. It's more programming oriented. We have some packages, and the facade is a facade to these packages, to the clients. The clients say, "I want that you want to do something for me." The facade has an operation called do something. And do something means if it is, well, he's doing something. You don't want to exactly what it is. So the clients only see the facade, and when they call it do something, then this lines of code will be executed. Okay, now we have another example. It's a very, but every year I think I have to remove it because it's one student said it's against women. Here is no woman, so I can only see the only look serious. Okay, you have a company. There are people who do some jobs. They have to use a computer. They have to do pencils, stamps of the sign of the company. Stamps. They have to bring what they have written and put it in an envelope and put a stamp on it. They have to bring it to the post box. They have to use a text program and they have to print it. And, yeah, well, yes. So you see a lot of interactions with all of these classes. All these members of the workers of the company use the same structure, the same thing they have to do. And all these workers have to know how all these things do work. So you can replace this with a secretary, female secretary, beautiful, competent, nice. So you go to her and say, please do it for me. And then she has to do it. And because she has to do this staff of work, she will optimize it. Because she has to do it now 50 times per day. And as a worker, maybe you do it once a week. So the secretary, that's the problem, it's a female. You cannot say in Germany, all females have to be a secretary. But I don't know how it is in Brazil, but in Germany, this discussion is at the moment is boring. Okay, so you see, we have reduced these many of interactions. Different people with different classes. These people can only communicate with one class, and this class is doing all these jobs. Fine, great, wonderful. This Java code, I generated, so that some of my students do like code. So you can see it's just, well, it's the code which is generated if you generate from this class. I always said that. Okay, I want to show you the difference between if you use something without a facade and something with a facade. This is the system, these are the clients. You will see they have associations with some classes. If you change one class, and this change, as a result, infects other classes in your subsystem. So, as you see, some, not all clients, but some clients are now interacting with classes that have been modified. And that can cause problems. If you have an interface or facade, then you have beginning one class more. Some people say, yes, I have to do more work because the facade is something I had to develop in addition to what I already have to do. That is true. Facade is some lines of code you have to develop as an addition to what you have already developed. It's more work at the beginning. And now, when you have a change here, the same is happening here, these other classes are affected, but the facade, you do change something inside the facade, but the clients don't realize that something has changed. Okay, I have clever students and some say, yes, Professor, but I don't believe that this is happening all the time. I'm sure we have modifications where the clients are affected. And they are right. Sometimes it does happen. So what do we have to do then? Okay, we modify this and we have to tell the clients we have modified the facade. It's one face, one facade the customer sees from our system. So it's a small amount of code compared to what the other way they have to see and modify and know. So it is reduced. For them it's much easier if you tell them, change a little bit in the facade, just look at it. And sometimes, yes, they have to modify the interaction with the facade. But it's not as difficult as they have no facade and have to look at every place in the system. Okay, that was an example. J-option pane is a Java. It's a facade dialog for Windows. And I'll show you the diagram. It's good. It's a very good facade, I think. One of the best I saw as a real living example. This J-option pane is hiding all of the complexity of these other classes. So you just have to know what is here important, and all the other stuff is hidden behind the facade. It's a beautiful example from real world. Okay. We have another problem, always problems in software development. I'm a developer of a system, and I supply a facade. You are the developers of another system, and you use my facade. Okay? You are developers of one other system. So what you can do is that all of you, 4 of you, use my facade. Over the years, the facade gets more complex, and you decide there's a better solution. You decide that the proposer is developing a facade for you, so that my system has a facade that you can attach to, but for you, Professor Poser will develop a facade where he is interacting with my facade, and everything you need will be in his facade. So you have 2 on each side one. So you don't not even know which system he is using to supply you the information. So he is the only one who has to modify things when I change things for you. So you just might go to him and say, okay, what do I need? How do I use this facade? We have on both sides here, facade. This is not called facade, we call it boundary. I don't know why. So a boundary is something where inside your system things are used as a facade, and usually you have one side a facade, on one side a boundary. And, the point is the same, you have controllers on the other side, entities with data. Okay. You got that? The facade. It's a great design. Any questions to facades? No, it's easy. What you may think is a problem implementing facade. Well, I can tell you. The problem is that you have to design a facade that it's just supplying what is necessary, and it's easy to change, easy to modify, and yes. And you have to know who will use your facade, because maybe it's for them, on the other side, it's better to implement their own facade to interact with mine and to supply their workers their own.
Just for example, the real world code
This one.
more practical.
more
I
practical.
mean, facade can be used to interact different programming language or not. I have a C application talking Java application through a facade. Let's say
Okay.
something like that. Or standalone application talking with a web application through a facade. Is it possible? What's the limitation? What's the limits that I can help you?
Okay, you have well, I don't see. I see that it's always a problem with programmers are using different languages. For example, you are a C++ company, I'm a Java company, and of course I will supply a facade which is Java-like. Okay. Even then it's much better because you have now a facade, very limited, which is in Java, and I'm sure you need one programmer, or a small group, who is able to use this Java facade and to supply for you internally a C++ boundary. But it doesn't match just by abracadabra. It has to be
When you are designing a facade,
Mhm. facade.
as design, can you foresee all possibilities?
No, you cannot.
So you can frequently update facade to update your clients, to update your.
I think first you have to, if you have large systems and plenty other systems are using it, or clients, you will have many facades. Because not
At the beginning, there is no facade. At the beginning, I made a
at the beginning.
class, and
Okay, I develop a system,
and I think it's a standalone.
Okay,
step
standalone,
and then
and
the
it's just
system goes.
okay.
And then you notice that there are many clients
Okay.
that are using, and then you have to decide, now I have to create a facade because I noticed that it's time to do that.
I think from the first moment other systems want to get something from you. From this first moment you should develop a facade for them. Don't let them enter your system. Lose coupling. That's the point. So, independently of the programming language, I would say that if you have good designers, from the first moment they interact with others, other systems, other clients, they are far away, they develop a facade. Because they don't want that other people look inside the systems. I don't talk about attacks, because attacks are more easy if you have no facade. They can enter your code, or if they can come inside your system, it's much easier for them to attack you. It's more harder if you have facade, because in the facade you can also integrate security aspects. Okay, from the first moment you develop facade if other people want to go to your system. How to develop a good facade? Well, a facade is something for someone else. So you ask me, I want to have the following data, or you are my customer. I want to sell something to you. I know what you want to buy, so I give exactly the data in the facade you need to evaluate or to decide what to buy. It is a very general concept, and how a facade exactly does look like is dependent on the application, programming language, how many companies are involved, how secure the system has to be, is it public or private companies who work with it. It's always a little bit different. But the facade prevents your system from that everyone has to know the inside architecture of the system. Structure. Is it okay for this answer? Maybe not.
Yes, when I was in Sweden, I attend a course at HLA. HLA is a framework for integrating different systems.
Okay.
I have a simulation, and I was integrated to that simulation. And
Okay.
They were not designed to talk to each other, but then you had to create this middleware, like
Okay.
a facade. And I asked him, okay, how long does it take to create this? A week, a month? The guy just laughed a bit. In some cases, made years to create this facade to integrate different simulators and exchange messages and different kinds of data that are exchanged among simulators. Very, very complex, near impossible. And today we use in our project here with the Army to enable our simulation to talk with other simulations. But in the case we have, the other is just one at this moment. Because if you want to make it compatible with others, maybe you can spend years of development because it's really, really hard. So I guess facade is more or less the same. Maybe very difficult, sometimes it may be simple, because the components are smaller than
well, simulation is, do you want to exchange the results of your simulation, or do you want to make simulations together?
Together. I want to put a vehicle from another simulator inside my simulator. So when it moves there, it moves in my one.
Okay.
So in this middle, there is the Agile, that's language, architecture, and API. I don't know exactly what it is, but to integrate and make applications talk to each other and exchange data. It's not further than a simple facade, but
yes, yes. Facade works very, very good in information systems. Very, very good, because you have to supply information. You want to know which planes are today flying from Santa Maria Airport. There is an application which knows all this information and is supplying it in a facade. What you want is a use of programs. Potentially, it's okay, it's the same. I do not know how many interactions you have. Well, maybe there are other, maybe, I don't know how complex it is. Maybe an adapter is more appropriate. Facade is the big sister of the little adapter, but sometimes the adapter is working better. Maybe that can help. I will talk about adapter as well. I think right now. I always start with a facade, but it's easy to understand and okay, today real world example. Coffee machine. That helps a lot. You wake up in the morning, you need a coffee. You're drinking.
I'm fine.
That's okay. Absolutely okay. But your wife does?
Yes, everybody does.
Not everyone, but
Everyone.
okay, so it is something you can make your wife happy. And you know the most important principle in marriage? Do you know it? You don't know? How long are you married now? he knows it, but have you an idea? The principle of a happy marriage is called happy wife, happy life. So if you make your wife happy, then you will have a happy life. Okay. We'll talk about adapter and composite patterns, and I will show you some UML class diagrams. First, I want to talk about different things we use when we describe systems, and what part do we talk about. If we talk about the architecture of a system, we include everything. Yeah? There are different ways to describe the architecture. Talk about architecture, we think it's everything in the system. A framework usually covers only a part of it, not all, and it has special features that you can extend the framework to include it into your system. We have patterns. Patterns are descriptions how small groups of objects work together. We have plenty of patterns. In a large system, you have implemented plenty of patterns. Components, which is another word, is that you put some classes together. Two, yes, only one. And because components have some good features, especially for exchanging one component by another. This is a coffee machine. Why is it in German? Sorry, it's the wrong file. It's the German version. The English version. This is a special coffee machine, and you have to put water in it. You have a boiler heater that you can heat the water. You have a water sensor telling you it's water inside or not. You have a pressure valve, which if pressure is too high, can be used to reduce the pressure. Yes, after it's heated, the water will be preshed through this pipe into the filter and receptacle, and we hope there's coffee in it, so we will have at the end coffee in the pot, and we have a plate heater which does heat the pot, so the coffee stays warm or hot, depending on hot. Anything I haven't explained? I won't. The warmer plate has 3 states. Yes, the warmer is empty, the pot is on it. The pot is empty, it's on it, and the pot is not empty, so it's coffee. And the boiler has 2 states. It's empty, so there's no water in it, or the boiler is not empty, there's some water. To brew, you have to fill coffee in, filter and coffee in the receptacle. You have to fill water in it, and when everything's ready, you push the start button. Then we hope we will have coffee and make the wife happy. I bring my wife sometimes coffee in the morning to bed, makes her happy. Okay. It has a light here, indicator light, and that lights up when the brewing cycle is over and the coffee is ready. So it's on when the coffee is ready. Pressure relief valve opens to reduce the pressure in the boiler. Drop in pressure stops the flow of the water to the filter. It can be in the state opened or closed. So if we, this is a technical system, we make a class diagram, and we make a whole part class diagram, we say, okay, the coffee maker consists of the boiler, the relief valve, the warmer plate, and the brew valve. And the boiler, there are two boilers, the boiler heater and the water sensor. The warmer plate has the plate sensor, the plate heater, and the indicator light. These technical systems give us an explanation how it is structured. But even it's a class diagram, the class diagram at the end will look completely different. In our technical system, we will see that somewhere I will integrate a controller. The controller will modify the structure quite a lot. The informations you don't have there. You start with the modeling of the classes, and if you do it good, this will remain during the whole life of the system. Technical systems at one stage, the design stage, you integrate controllers. The controllers will modify the structure of the system. Use case diagram. You know it? No? Okay. It's one of the UL diagrams, and we have here the use cases. On a very high level, we describe what the system will do. It will brew coffee, you can pour coffee, and you can interrupt the brewing process. You have the actor, we call him the coffee lover, or the husband of the coffee lover, and he's interacting with the machine to brew the coffee, to pour coffee, and to maybe to interrupt it. Okay? So this is use case diagrams do look simple. And compared to other diagrams, they are simple. But they have several advantages, but one I think sorry. Big advantages of the use case diagrams. Use case diagrams are complete. If we have done it right, it's a complete description of the system. Class diagrams are complete. All classes of the system have to be on the class diagram. On the other side, you have sequence diagrams describing the sequence of operations inside the system. They are not complete. It's nearly impossible. Only simple problems can be modeled completely. It's just a way to make possible that how can an interaction be. Okay, main big point, that you have to remember that the use case diagram is always complete. Okay, this we have to leave out because it's from software engineering. The column of the stakeholders, it's not so important today. Then we describe. Each use case will be described in more detail. So he has a name, which system does it belong to, who is the actor, and does it have any preconditions. Then you have steps, and in this case we describe what is happening if in this use case. Okay, we put an empty pot on the warmer. If it's boiler water with water, boiler with water, we put filter and coffee grounds into the filter holder and load it into the receptacle. Then we push the brew button. The system then starts. It closes the relief valve to allow water to flow to the receptacle when it's hot, and turns on boiler heater. When the boiler is empty, it turns off boiler heater, and the indicator lights also turns on, telling us the coffee is ready. So software development is a lot of doing things which is not programming, which is just documenting things. You know that on systems today, not only one person is working, maybe 1,000, 5,000, 200 people. So you need a valid documentation. Unfortunately, the computer scientists have to apply that. Okay, the second is you pour coffee, kills the coffee lover or the husband of the coffee lover. The actor is the actor as a precondition, and the precondition is that the coffee maker is not brewing. So you lift the pot from the warmer, the system detects that the pot has been lifted and turns off the plate warmer. The indicator light is on, then turn it off. We replace the pot on the warmer after we pour some coffee into the pot. And if there's coffee remaining in the pot, we start the plate warmer. So still coffee in the, we poured some out. Okay, in the morning, time is short. The coffee lover or the husband of the coffee lover has to interrupt the brewing because his wife wants the coffee now and not in 5 minutes. So you must develop a possibility that is possible. But brewing is in process, still using brewing. So if you remove the pot from the plate warmer, then you turn off the boiler and open the pressure relief valve so that not more water is running through the machine. After we have poured some coffee in the cup, we turn the pot to the plate warmer, and then the boiler turns on and closes the valve and continues the normal brewing cycle. Okay, we have to develop a way that we can interrupt the brewing process like this. So you see, it's a lot of this, a lot of documentation. Now comes what I tell the students is different to information systems. If you have a technical system, at this point, first design, you integrate something which is a controller. Controller who controls the system. It reads the information from the brew button here, the plate sensor, the water sensor, and it controls the valve, the indicator light, the heater, both heaters. That is a typical, very, very typical design of a technical system. At one point, one step in the development process, you integrate controllers. Now we want to come to what is called an adapter. We have an on-off device. You can turn the machine on and off. And we have an open-close device, which is the valve. Now we think, okay, can we use the open-close device with the on-off features? Or the other way around, can we use open-close to the on-off device? So we design an adapter in between. We call it the open-close adapter. It's a specialization of the on-off device. And here we have operations that we adapt one interface to the other. Simple Java, it's off is matched to open, on is matched to close, and the question is on is not, the device is open. Now we can use on-off as open close. Yeah, now the discussion a little bit. Speed up a little bit. If we say open to the valve, it's open. If we on to the valve, then it's open or closed. So, of course, if we have programmed correctly, it will do what we have programmed, but from the code, it's not easy to see if you have what you were doing. Okay. So, using adapters is fine, but the adapter has to be properly named so you have an impression what is going on if you use these adapter operations. In real life, we have adapters as well. The power adapter, and here it's a VGA, I think. It's a graphic adapter. Yeah. We don't use it anymore, nor do we use it still? I think we have removed the last ones, the last screens, monitors with VGA last year or a year ago. After Corona, we made a change. Okay, what is the idea of an adapter? The interface of an existing class can be used as another interface. We use it to make existing classes work with others without modifying their source code. That's the point. The source code of both to remain. Here that is very easy, but of course you can have source code which is quite complex. So the adapter makes it possible to use the other interface without any modification. Okay, this is a problem that the adapter pattern can solve. Other problems it can solve, so I will leave it to you. A little bit late. I will move a little bit out of the adapter point. Okay. This is state diagram, you know? Very much used in technical systems. So you have the brew controller who is off, is done, or is brewing. So at the entry of the off state, the boiler is off, the valve is open, and the light is on. Then we push the brew button and go into the state brewing. Then the boiler is on, the valve is closed, and the light is off. Still off during the brewing process. When it's ready, the tank is dry and it's ready, it's going to the state done. Then we turn the boiler off, the valve will be open, and the light is set on. Just use these slides to repeat from the third semester the UML diagrams that the students have the idea, have learned value things. Okay, when we have the brewing process, we know that the pot can be removed, so we have to model it. So inside the brewing process, when the system is on, we have a brewing process and we remove the pot. And it goes into the waiting state. Put the boiler off and the valve will be opened. Then can two things happen? We go into the brewing process because the pot is empty and we put it on the plate, or the pot is still some coffee in it. And then it's going to continue on brewing. Until the tank is dry and we go to the done state as we usually have it. So you see that you have to model very carefully if you have to use dates. And you have to, yeah, model that properly. You're a member of this, the manager of the company, developing hundreds of different coffee machines. So you tell your developers, why do you always develop the same software for every system? Make me a solution which is appropriate to every 100 different coffee machines. So the people do make this, for example, they verallgemeinert, make it more flexible, open. They used words more general. To let these software run on other coffee machines, maybe on other devices, on other on-off devices. Do you think it's a good idea? Make things as much as possible general. Well, you cannot answer that without looking at the special case you talk about. In some cases, it's an advantage. In some cases, it's not. At the end, we try to develop software which is flexible against modifications. If you have developers of this coffee machine company, and of course, coffee machines have every 2 or 3 years they have a new machine. And if you have all the time, you have to write all the code new, then it's a disadvantage. So it's better to reuse code. Do you know one of the, I know it because some of my colleagues work there, some of the worst reuse of code, one of the know it, that it was a reuse, and this reuse caused problems. It was the first flight of Ariane 5. I don't know, you remember, you are too young to remember. I worked with Daimler-Benz, and I did projects for this aerospace and Airbus company. So some of my colleagues were on this Ariane 5 project from Bremen. And they had not a lot of time to develop software for the new Ariane 5. So what they did was they took the software of Ariane 4 and put it into Ariane 5. And they tested it quite a lot, but found no errors. So they sent this Ariane 5 with the software, with the maybe a little bit modified software, but at the end still the software of Ariane 4 to Kourou. It's on the south, it's close to you, far away from us. It's a little bit north of Brazil. And they started this rocket. It started as it wanted, should be. And then it flew like this. And then they had to destroy the Ariane 5. So it's most of pressure firework with the highest cost in the world, 1 billion euros. You can see it on the internet. I can show it on the Monday morning to wake you up. And the reason after that, of course, it was public money. They tried to find the error. And they found it was a fault of, it was a software fault, and it was not possible. They had tested it quite good, but they didn't have tested it on the southern hemisphere. So on the southern hemisphere, things are different. So that he decided, on the northern hemisphere it was like this, and the southern hemisphere it was like this. That was the whole problem. 1 billion euros down. Quite a big fault. Why do I think? Okay, so it's the reason that it's not possible to transfer all the time software from one unit to another. Bad example. Okay, this is at the end the system, wonderful start and stop controller here. This is the system as it is at the end. I will move to the composite pattern. A composite pattern is a little bit more difficult than the others. A composite pattern has it's a whole part structure. We have something which is a whole, and it is divided to parts. And the most known example for composites is graphical user interfaces. You have a window, you have a part in the window, and you can say everything, every part is a composite, something which is consisting of some parts itself, or it is, we call it a leaf. It's a basic structure which will be it's not a composite of others. So here we have the composite pattern for on-off devices, and the trick is that you have here this composite structure. It's an aggregation, and here is specialization. So the on-off inverter is specialization as well as the on-off composite. So an on-off device is consisting of on-off inverters and on-off composites. And an on-off composite is an on-off device consisting of on-off inverters and on-off composites. And an on-off composite is a special on-off device consisting of on-off inverters and on-off composites. At the end you have all on-off inverters in the tree. All leaves cannot be further refined. Are not composites anymore, all are basic structures. So the composite pattern describes a group of objects that are treated the same way as a single instance of the same type of object. The intent of a composite is to compose objects into tree structures to represent whole part hierarchies. Implementing the composite pattern that clients treat individual objects and compositions uniformly. That is because they are both specializations of of their main class. So a composite pattern always looks like here on the left-hand side. You have an abstract component. You have an operation on it, many operations on it, and you have two specializations. One is a leaf, which cannot be further refined, and you have a composite, which is on one hand side a component, a special component. On the other hand side is does consist it is a component and it does consist of one to many children. So at the end you have a structure like this. You have a composite 1, which does consists of one leaf, another leaf, and another composite, and this other composite does contain of leaf 3, 4, and 5. So if you remember the example of the graphical user interface, where you see that you have basic structures which will not be further refined, and you have other structures like this here that can be refined at least once. Same. You know these kind of class diagram and you can read it? Or is there anything you doesn't understand? General specialization, inheritance, and this is association. Exactly, it's an aggregation, one to many, so composite is a parent possibly multiple chunks. Component itself is always an abstract class, sometimes interface, and it describes abstract operations. Leaves are simple objects, and the composite is a component, specialization of the component. It consists of leaves and or composites. Okay. So you can design these whole part structures. I will just start with finish something which is called factory. The factory is the idea that we organize, how we organize the creation of objects and where we do creation. Usually you can say, well, I can create everywhere in my system, I can create objects everywhere. But this has undesired side effects. So we have decided to create objects always at the same place. That's the idea of a factory. Why is it called factory? Well, if you produce cars, you don't produce it in every corner of the town, you just have a factory where you produce them. We have advantages if we can produce objects at one special place. We talk about these three factories. A simple factory I will do today, and factory method abstract factory will be done on the Monday. For new objects, it's a new operator. If we have a duck, we can say a duck is a new male duck, then we have a new duck. The code looks like one duck. And if you have a picnic, like it's a male duck. If you are hunting, it's a decoy duck. And if you have a small child and a bathtub, it's a rubber duck. And rubber duck can fly, but not really. They just can be thrown to the head of the father, not to the head of the. Okay, let's look at pizza. Your best friend offers a pizza shop, and he's telling you, okay, I need some program, so please write a program for me to make pizza. And you say, no problem. If someone's ordering pizza, I create a new pizza, and I prepare it, I bake it, I cut it, I box it, and I return the pizza. What is the problem? That's not a problem, isn't it? No, we can do it like this. No problem. But we can do it better, even if the system gets more complex. We have a pizzeria with more than one pizza. Someone likes cheese pizza, lots of cheese on it. Greek pizza, with a lot of garlic and seafood, and whatever. And pepperoni for the girls who are vegetarian. Do you have vegetarian girls here in Brazil? Not a lot, I think. Yeah, but you have, yes. Okay, so now you have to extend the order pizza with a parameter which does include the kind of pizza you will prepare. Okay, so we do it. Now you have the feeling that you see that Greek pizza, that you don't like it, Greek pizza, so many people obviously do not like Greek pizza, so it is not sold anymore. But there are other pizzas from your other pizzerias, you know, which are sold quite good, which is vegetarian, and what do you call it? Clam? Clam, I think it's clam. pizza, seafood. How do you manage that? Okay, you have to go into your code, you remove the pizza, Greek pizza, and you add clam, which is seafood, and a special veggie pizza for the women who don't eat meat. What is happening here? Of course, everything's correct. It works. But what do we do not like? We do not like that we have to go into the code and change the code. It's one principle we try to follow. It's if you have something which is running properly, it's closed to modification but open to expansion. So can we use this principle here in this case? Let's look. We take this is part of code which has obviously changed many times, will be changed many times, into a separate part. And the rest is the same. No modification. Okay, then we have we make a public class. It's called Simple Pizza Factory. Now we have a factory of pizza, and we create pizza. Here's a string, and this. And now we have moved these lines of code to this place, and yes, we have removed it from the other part. So we have now a place where only this code is, and where we only can, if we want to add or remove pizza, we can remove it here. Okay, now we have this pizza store, and you give the factory to the pizza store, and you say, let's look what's happening. Here we have what's always the same. Now we have a pizza, and we say to the factory, please create your pizza of this special type. Wonderful. If we look at the class diagram of this simple factory, this is started to the factory idea. We don't talk to the pizza class itself, we have a pizza factory in front of it. And this pizza factory has an operation called create pizza. The pizza itself does have the operations prepare, bake, cut, and box. And here you have the different kinds of pizza which will be produced. Okay, I would like to stop here because we are close to 12. Next step, the factory method, is a bit difficult. Do you understand this? Okay, that's great, because everything what is following is based on that. This is Java we write, but of course you can write, you can make it with C++ as well. Okay, so we will start on Monday morning. I will show you the crash of the Ariane 5 to wake you up. Then I will continue. Now I see in your faces that you ask me where is the English version of these things. My assistant is doing is working on it, and I think you will supply it today, tomorrow. Now it's your weekend, and at the end we will have it next week. I said to you, you can make these exercises, these tasks. Even I'm not here anymore, we can, at the end I can say, okay, you did it, you did it. You spent so much time to do these exercises, to fulfill these tasks, that I can give you the amount of hours that is that you need for your structure. Okay? So, we don't see us this afternoon, because we cannot do anything. So we will see us on Monday, 10:30. Thank you very much for coming and not sleeping. Sometimes life is hard.
Next time, bring the pizza, please. Yes.
Okay.
We missed the pizza.
We will make.
I was missing the pizza.
You will missing the pizza. I will make a lot of pizza. Chicago pizza, New York style pizza.